I believe we can start. People will keep on joining us, right? So, hi everybody, welcome to Mining Devs. Today we have Nick Kalyani with us. He's the founder at Decentology, and what we are going to show you here is a quick way to get started in smart contract development or blockchain developer or as a blockchain developer, right? Nick, I'd like to share some words, and you can get started with the lecture as well.
Great. Hello, everyone. How are you? Good morning. Good evening, I guess, for you.
Yes, please.
I'm really excited to be here today and presenting to you. Give me a moment. I will share my screen and we'll just get started here. Here we go. Share the screen, and hopefully it will be visible here momentarily. And we are up. All right. So our topic for today is learn how to build Ethereum dApps. So Ethereum is a public blockchain, and I am going to, in the course of the next hour, share with you how you can just dive right into this amazing, cool new world of blockchain, which we loosely call Web3. So first of all, a little bit about myself. I'm Nick Kalyani. I'm the co-founder and CEO of Decentology. I'm based in Mountain View, California. It's bright and early for me right now. It's 5:30 a.m. And I've already done one webinar at 2:30 a.m. So I'm fully caffeinated and ready to kick ass. A little bit about Decentology. So our mission is to onboard sort of the first 10 million developers from Web 2 to Web 3. We just love developers. We make products that make their lives simpler. And about a week ago, we announced the close of our seed round of $4.3 million in funding to achieve this mission. Our product is called Dap Starter, which is what I'm going to tell you about today. And the role of Dap Starter is to accelerate and simplify your blockchain development journey. So you're going to learn all about it. Now, as a company, one of our goals is to help end the gender inequality that exists in crypto and in tech in general. And so what we are doing is we want to make sure that women are well represented in this ecosystem. And so for all the women who are attending here today, you will be eligible for a scholarship to the University of California, Berkeley, for their course called Professional Certificate in Blockchain Fundamentals. It's a $200 value. So here's how you get it. You have to be a woman. You have to attend this webinar, which you're doing now, and you have to simply create a project with Dap Starter. And as you will see during the course of this presentation, it's trivial for you to do that. And the protocol is in the chat. You will just enter girl power and your first name and last name. And then you need to essentially email us to scholarship@decentology.com, your college ID. Once we get it, we will send you a link. You follow the link and you get enrolled in that course. I'm going to go ahead and paste these instructions into the chat so you have it. And I hope all the women in the audience will take us up on it and sign up for this really awesome course in blockchain fundamentals. So I will look for you to respond here. All right, so continuing now, what I'm going to do is walk you through some basics of blockchain, and then we'll get into Dap Starter. So let's start at the beginning, but before I go there, I want to take a quick poll. Can you raise your hand if you're familiar at all with blockchain, even if you have a passing idea of what it is? I'd like to get a sense of what it's like in this audience. So just raise your hand. All right, so we've got a couple people here. All right, more than a couple people, great. So we got Ayush, Kuldeep, Pratham, and Ayush lowered his hand, so maybe you're not sure. Well, after this session, hopefully you will be sure that you know a little bit about blockchain. All right, so blockchain is essentially a new technology. It's also called distributed ledger. And it's the main highlight of blockchains is that it's decentralized. It doesn't rely on any centralized company or organization, like for example a Google or a Microsoft or someone, in order to have this architecture. The basic blockchain workflow is that someone submits a transaction, and you'll see what that means in the course of the webinar today. That transaction is broadcast to a network of computer nodes that are operating using peer-to-peer software. The nodes validate that transaction using known cryptographic algorithms, and then that data from that transaction is added into a block along with other transactions and tacked on to a list of blocks that already exist on the blockchain. And the key thing about this is that once that data is added to that blockchain, it becomes immutable. You can no longer change it, and it will exist forever. And the blockchain keeps on growing infinitely in this manner. So that's a real high level view of blockchain. There is ample subject matter on this that you can Google and find out. So I don't intend to go into deep details about it. We're going to focus on application development on blockchains. And the way applications are developed on blockchains is with something called a smart contract. So many blockchains have the ability to run applications. These are commonly called smart contracts, and they can be anything. They can be games, they can be tokens, they can be cryptocurrency, etc. But there's three aspects of smart contracts that are very important. The code you write for a smart contract, which is the program, once you deploy to the blockchain, it is immutable. In other words, it is not possible to change it. So you need to test it and make sure it's working correctly before you deploy it, because if there's a bug, it is there forever. There is no way to delete that once it's uploaded. There's no way to change it. But as you will see today, there's ways in which you can architect an application and partition it in such a way that you can have a little bit of flexibility and are not stuck if there's a bug in your code. When a transaction is submitted to a blockchain, it costs money, and that money is called gas. It represents each line of code that has to be executed. Now you're wondering, well, why is that? Like when I run a program on, some application I deploy to Heroku or something like that, I don't have to pay any money. Well, this is the point of decentralized networks. There is no single owner. Typically, when you are running code in a centralized environment, someone is paying the bill, just not you. Maybe the company that's providing those services, like Google, etc., is providing those services for free because they are making money somewhere else through advertising or something else. But in a decentralized environment, there are no owners, and every node is essentially a volunteer node. And in order to use their resources, they have to be paid. And so when you submit a transaction, it automatically computes the amount of fees that are due, and that's called gas. It's not substantial amounts, it's small. It depends on how busy the network is. If it's really, really busy, then it can get to be very expensive. But if it's not busy, it can be much cheaper. And it also depends on the blockchain. Some blockchains are negligibly, like the cost is very low, and on some others, it's much higher. In blockchains, you typically have the ability to store some data, but a blockchain is not a database. It is not designed to have large amounts of data. So to give you an idea, if you were to store around 500 megabytes on a blockchain like Ethereum, it would cost you like $1 million. And compared that to something like Amazon Web Services, where 500 megabytes might cost you, I don't know, less than $1. So blockchain smart contracts should only have the data that is relevant to that application, and the other data that you need, maybe you have images or video or anything large, you store on outside networks that are called decentralized storage networks. And there's several of those. There's one called IPFS, which we will see today. It stands for Interplanetary File System. There's one called Skynet. There's one called Fleek, which allows you to interact with these, etc. So I'm going to paste some of these links here in chat so you can check them out. Let me do that real quick, and then we'll continue. Speaking of chat, I'm looking forward to having you post your questions as you come up with them. I'll be looking at the chat periodically, and we'll be able to answer your questions live as they come up with. So don't be shy. Please ask a question, and I will be happy to address it. So let's continue here. So what I want to do is I want to compare and contrast Web 2.0, which is our current centralized application architecture, with Web 3.0. So this slide shows you your current application architecture in Web 2.0. On the left, you've got a desktop and a mobile client, and then they interact with a web server. Now that web server might actually be a cluster of servers. So the singular term there indicates that it's representational of one entity, but it could be a cluster for scaling, etc. The web server typically connects with either a single or a cluster of API servers, and those in turn might interact with a database server. So this is your typical application. You can have lots of variations around this. You might have a web server that interacts directly with the database server. You might have one server that has everything on it, etc. But in general, architecturally, this is the workflow of a Web 2.0 centralized application. Now, let's look at what it's like in Web 3.0. In Web 3.0, decentralized applications, which are called Dapp, and that's the term I'm going to use for the rest of this webinar, are more or less similar, but they have some important differences. So on the left, we've got a web or a mobile client, and that's interacting again with a web application. So if you see, it's HTML, JavaScript, and CSS. But here's the cool thing. That can be hosted anywhere. You can run it off your local desktop, but obviously then only you can use it. But you can also put it on these services I shared, like Fleek or IPFS, etc. And then they're decentralized. In other words, no one can shut down your application. You don't have a bill to pay. Your account cannot get locked out. It is impossible to shut down that application once it's online. And that is what makes decentralized applications so exciting, because all over the world, there are regimes, there's dictators, etc., who are there to suppress people's right to speak freely. And with decentralized applications, you have a way to essentially circumvent all that. Once you put a file or an application on things like SIA or IPFS, it can't be deleted and no one can block it because it's worldwide. That application interacts with your smart contract on any blockchain node. So a blockchain that is popular will typically have hundreds, even thousands of different nodes. Your application can point to any of those. You just need to know the URL of one of them, and you can point to it, and it can interact with the smart contract. It doesn't matter which one you interact with. They all sync and stay current. So your application can work with any of the nodes. So those are some important characteristics of decentralized applications. Now, I just described for you the client Dapp, as we call it, and the smart contract. And you can see from my bar here, roughly, that the client Dapp is around 70 to 80% of the application, and the smart contract is not that big of a component. So that's deliberate. Smart contracts are not designed to be these huge, complicated applications. They're very simple, and even the term contract is a bit misleading. It is an application. It has simple functionality. And depending on the blockchain you're working with, the language in which you create a smart contract is going to vary. So on Ethereum, it's going to be Solidity. On the Flow blockchain, it'll be Cadence. On the Solana blockchain, it'll be Rust. On some other blockchains, it'll be TypeScript. So depending on which blockchain you end up developing for, you will learn one of those languages. Today, we are focused on Ethereum, and it'll be Solidity. Now, here's the thing, though. As a Web 2 developer, if you know how to do HTML, JavaScript, and a little bit of CSS, you can fully participate in Web 3. It is not necessary that you know how to code smart contracts. You can just build a web app that interacts with smart contracts that other people have built, and that's perfectly okay. So if you're a web developer today, you already have 70 to 80% of the skills needed to be a Dap developer. So building for Web 3 is an awesome way for you to add to your talent stack. So the bigger you grow your talent stack, the more viable and the more attractive you become as a professional developer in this space. So let me share with you some numbers on why you may want to consider this. So on this slide here, there's blockchain developer salaries from different regions of the world. And currently there is a huge demand for people who have blockchain application development skills. That's off the charts. It's like people who have these skills, they get hired almost right away. And you can see that these are fairly decent salaries. I would say they're well about decent. And because crypto is global and because blockchain is global, generally no one cares where you are. You can work from anywhere and command a salary of the region you're working in. So you could be in India and you could be getting a US salary, and that's perfectly valid. So this is really, really exciting. And this is our mission is to onboard 10 million of Web2 developers, and help them learn blockchain, because this is the future, and it's really, really exciting. So with that kind of overview out of the way, what I'm going to do now is dive into a product demo of Dap Starter. So Dap Starter is our product that helps you build a decentralized app very quickly. So I'm going to switch my browser here. But before I do that, I'm going to take a quick pause and see if there's any questions anyone has about the material that I've covered so far. I'm not seeing any responses from any women, so that must mean that there are 0 women in the audience, or that none of them are interested in an awesome blockchain training course from the top university in the world for this kind of thing, which is UCLA Berkeley. Yeah, I'm not seeing any women posting here, which is kind of interesting. The first webinar where I have not seen any women posting. Are there any women in here? Oh, I see a few. So hopefully you guys will add your names here. All right, Deepshika, you are here. Yeah, so please do add girl power and your first name and last name in there, so I know that you're interested in this, and we'll get you signed up. All right, let's get going with Dap Starter. So Dap Starter is a web application. It's a code generator, and its purpose is to help you get started. And the way it works is you first choose your blockchain. So today we are choosing Ethereum. The language is Solidity. The frameworks are JavaScript and React. So vanilla JavaScript or React. I'm just going to leave it vanilla. And then down here, what we've done is taken common smart contract design patterns and made them into modules. So every box you check here is a feature that's going to get added into this. Oh, thank you, Deepshika. Thank you so much for adding that to the chat. So I'm first going to choose contract run state. So this is a simple module that allows you to pause and unpause your contract. And we'll see its functionality in a bit. There's a bunch of others here, but I'd like to, for today's demo, use IPFS. So what this module does will allow us to upload a couple of documents. Those documents will get stored on IPFS, on the decentralized storage, but a reference to those documents will get stored inside a smart contract, which is the correct design pattern of how you should implement it. So Pratham says, could you maybe zoom in the browser? Yeah. Hopefully that's a little better. Yeah. So just to review here, I chose the stack, I chose the language, I chose that, and then here's the contract run state, and then we chose IPFS. All right, so then we keep going on here, and at the end of it, we have to give our app a name. So I'm going to say demo, and then we say create Dap. All right, so what that's going to do is it's going to start a process on our server, and it's going to dynamically create a new GitHub repo for us, and it's done. So I see more women responding. Thank you very much, Himashri. All right, so now I will click on this and show you that there is a GitHub repo that's been created. So this is the full stack source code for a project. We are going to go through it, we're going to explore it, and we're going to run it now. All right, so let's go ahead and copy that link here. And then over on the right, I have Visual Studio Code running, and I'm going to do git clone and get this repository that was created for me cloned. Let's open it. It's right there. And we have this. So you can see here that we've got all kinds of stuff in our project. I'm going to explain what it is in a moment to you. But while it's doing that, I'm going to start the dependencies installing So typically when you have a Node.js kind of application, you do an npm install or a yarn, depending on which one you're using. We are using yarn. So it's going to get all the dependencies going, and that takes about a minute. So we'll do that and get that going. All right, looking at this here, we are using multiple packages: client, daplib, and server. Now, daplib is the most important and significant one. It has all the contracts, and it has all the source code that helps you interact with the blockchain. And we're going to go through that. So let's look at the contracts first. So in here, there's a bunch of files with an SOL extension. The SOL extension means it's a Solidity source code file. And let's look at one of them. So there's this one called Dap State. And you can see that this is fairly heavily commented, and that's deliberate. The code that's emitted by Dap Starter is designed for you to modify, for you to understand and work with. It's okay if you don't modify it, but you certainly should be able to understand it. And so we take great pains to heavily comment it. I alluded earlier to the immutability of your code. So we have this architecture where Dap State has all the state information, meaning the data, but the application logic is mostly in Dap. And what that does is this architecture, if you implement it, makes it possible where you can, if you find a bug or something in your Dap, you can ignore the existing one and deploy a new one, which then starts interacting with your state. So that's the way to sort of work around the immutability problem. So in just a moment, the code here is going to get done figuring out the dependencies, and then we'll get started with actually running the Dap Starter scripts, which will run a local blockchain emulator. So we will actually have a simulator emulator in here that simulates how blockchains work, and it will compile our contracts, it will deploy them, it will create test accounts for us, and then it'll start up a web server, and it will compile and package up our client, which I'm going to go also over, and it's going to deploy that and start up our application. So we are moments away from doing that, and once that happens, we will actually interact with the UI a little bit, and then you can see how that actually looks like in source code. So it's almost done here. There we go. It's all done. So all the dependencies are in, and as expected, there is now a node modules folder here, which has all the dependencies. Okay, let's kick off all this by typing yarn start. And what that's going to do is start first with compiling our contracts, and then it's going to deploy them. So you can see that it's done that, compiled the contracts, then starting to deploy them, and it's deploying them to an emulator that we started off with. So all this stuff that you just saw go by is basically that deployment stuff happening. And now it's going to launch our app. It actually fired up in my browser in the other window. So I'm going to go here, and it's almost ready to start. And there we go, dappiness. So now we have a fully functioning environment here, where in the left side, I have my browser with my application running, my Dap running. And on the right side in my Visual Studio Code, I have a blockchain emulator running, a web server, or two web servers actually running, one for the client and one for the server API. And let's check out what's going on here. All right, so here is something called the UI harness. And what the UI harness does is enable you to start interacting with the features you have chosen right away. So you can get a feel for how they work, and then you can also get a feel for how you should modify them. So let's start with contract run state, which, as you recollect, gives you the ability to pause operation of your smart contract. Now, the way we've designed it is Dap Starter is there to make your life easier. And so what we do is we put in a nice UI. We call these action cards for you to be able to interact with the smart contract code. So I'm going to pull up, well, actually, it's already up here. So here we have one card that is green and view. So whenever it's green and view, it means it's going to read from the blockchain. And then here that's orange, and as the word suggests, submit, it's going to write to the blockchain. So let's first start by calling to see if the contract run state is active. So we do that and it returns yes. So what actually happened there is that it called in our contract this function here, is contract run state active. And you can see from the source code that the syntax is very much like JavaScript or any C-based language, C#, Java, etc. But it's got some differences. It's got some scopes here. It's got a returns with a Boolean type here, and so on and so forth. So, so Manpreet asked, where have we deployed our app? So it's a really good question. If you go back to when this thing started up, I'm going to scroll up here, and it's going to say that there is an emulator starting up. So there's an emulator called Ganache, and we actually are running that for you. So here we go. So here's accounts being generated, and it says here Ganache. So this is a blockchain emulator. So we don't want to be developing against the public blockchain because A, it's slow, and B, it would be very inefficient and expensive. So we have an emulator on running in there, and Dap Starter handles it for you. You don't have to think about it. It's automatic. It just does it. So getting back to this, the contract run state is currently yes. It called this function, and I'll get into how it called it in just a moment. And so now what we want to do is we want to change the contract run state. So if you pay attention on the right-hand side terminal output window here, I'm going to go ahead and submit this one here. And what that's going to do is submit a transaction to change the value from true to false. So we'll do that. And that happened really quickly, but you can see that there was some gas usage, and you can see a transaction was submitted, and that same transaction status also appears here. So whenever there's a transaction done on the blockchain, there's always an identifier that tells you what that transaction is, and that's called a transaction hash. It's usually a long hexadecimal number. All right, so if this worked, our contract run state should have changed. Any idea on what it will say if I hit view now? You are all in NIT, so I expect that you should be able to answer this question very easily. What will I get if I hit this view button as a response, knowing that we've paused the contract? I'm looking for at least one person to respond. Should be a no. Yes, thank you. Pratham Gandhi comes through. Awesome. Yes, and it is indeed no. So as expected, our transaction worked and the contract is turned off. So let's turn it back on. But before I do that, I want to show you the code in the contract. So this is the code that's going to change it. And you can see that it's expecting a Boolean. And so Pratham is asking what exactly is gas. And so as I explained earlier, gas is the monetary value that has to be paid with every transaction. It is not possible to submit a transaction to a blockchain, any blockchain, without paying a fee. That fee varies, and it is called gas. So gas is payment for changing the state of the blockchain. Like I said earlier, in Web 2, the fee is being paid. You just don't know it because someone else is paying the fee for you. But in blockchain, it's decentralized. So when the code is running, whoever is calling that code is responsible for paying the fee through their wallet. So there's something called a wallet, which we'll learn about at a later time. So when I execute the set contract run state, this is the code that's being called. But this is Solidity code. It was compiled and deployed. How does this, which is in a browser, interact with this? Well, that's where some exciting code here in the source folder of daplib comes into play. So what we've done in Dap Starter is we have created this thing for you called daplib. And what daplib is an abstraction. It makes it super simple for you to interact with the blockchain. The basic pattern of a JavaScript function in daplib is that it calls asynchronously this library called blockchain with either a get or down here a post. So this, as you might imagine, is analogous to Web 2.0 REST, we deliberately named those things get and post so you could be familiar with it. Get reads and post writes. So this approach makes it super simple because all you need to do is specify the name of the function that you're calling in Solidity. And if you have any parameters to pass to it, you do that. So like here, for example, we want to pass what should the mode be? Should it be true or false? And this one is going to post, meaning call this function set contract run state and change the state of it. So the essence of your development is workflow is going to be modify the contract code and then modify daplib to interact with it. And that's really all that you have to do. All right, so that's one simplistic sort of function. I want to make sure that before I continue, I do turn the contract run state back to yes and on, because otherwise things are not going to work. So let's go ahead and submit one more transaction, and that got submitted, and you saw there was gas usage there. Let's just double check, view, okay, contract run state is active, very good. All right, so now let's try the other module that we added called IPFS documents, which is a little more exciting, and let's see how that works. So as I mentioned to you, the purpose of this feature is to be able to have you upload a couple of documents or any number of documents, put them on IPFS into decentralized storage, and then have a hash for it stored locally. So let's actually demo that. So as you see here with Dap Starter, a lot of the UI is auto-generated for you. You don't have to use this UI, but you can if you want to. So I'm going to browse these files here. I'm going to choose a couple of photos here. Let's choose that one and hit open. All right, so those are on here and ready to be uploaded. So I'm going to hit submit, which is going to transfer these to IPFS. And let's do that. I hit submit and it's done. And I get a URL back for these documents submitted to IPFS. So let's click on that URL and see. And you can see that these photos were in fact uploaded to IPFS. Let's verify that. There's one of them. And there's the other one. And you can verify that for yourself. I'm going to take this hash that was generated and put it in chat, and you can check it out. So now these two photos are immutably stored on the IPFS network, and they cannot be deleted. So this is, and getting back to our application, you can see that in addition to the URL, it generated a doc ID. So I mentioned that it's going to update a reference to these files in the contract. So let's copy this doc ID and query our contract. And if everything has gone according to plan, this, when I click view, is going to read from the blockchain smart contract and show us this document ID. Let's do that. And you can see that it did in fact return the exact same URL and has the correct data. We can also do a check by user. So I'm currently signed in as a user called admin, but I have a few other test accounts here. So if I select, for example, Birbal and hit view, Birbal owns no document right now, so the result is nothing. Admin has this document we just uploaded, and we view it, so you can see that that same document ID is present right here. Let's look at the source code for this to help you understand what really happened here. So I have functions here that essentially are related to IPFS, etc. But I want to draw your attention to line 65 here. This says mapping bytes 32 IPFS document IPFS docs. What does this mean? So this is a dictionary. In most programming languages, there is a dictionary that allows you to have a key and value. So the key here is in 32 bytes, and the value is this data structure here called IPFS document. So it's got a doc ID, it's got a label, a timestamp, an owner, and you can see that kind of mirrors what's going on here. It also has this thing called a doc ref, which is a compound object type. So it has all these properties here. So here's the important takeaway from what I'm just showing you here. A smart contract in a blockchain is your code, but it's also your state data. So IPFS docs here is actually a state variable in this contract, and it holds the data that I'm manipulating here. So this is an important thing for you to understand, is that in your typical Web2 app, you have the application and then you might have a database somewhere. This is not true in blockchain. The smart contract is a unified application and its data, and only the contract can change its data. And this is what makes blockchain smart contracts so amazing, because the contract code, once written, cannot be changed, and it will forever follow the rules that are embedded in it. And so that's why the term contract, it is a lifetime eternal contract in code, and the data can only be manipulated via the functions of the smart contract. So if you in your functions here have certain qualifications or checks or whatever before the data can be changed, that'll be enforced forever, and no one can circumvent it. No one can get around it. No admin can go and say, you need to in a hurry change this. I'll do it for you. Don't worry about logging in and all that. You cannot do that. Can you share the recording of the session? Yeah, I think that will be shared with you. It is being recorded. So yeah. Okay. So that is basically the concept of the UI harness in code. Now, what I want to do is show you a really cool feature of Dap Starter, and that's hot loading. So in order to make your life easier as a developer, everything here, the contracts, JavaScript code, etc., is set to hot load. The moment you make an edit and you hit Control S in Windows or Command S in Mac, it will reload, recompile, redeploy, and do everything for you automatically. You don't have to think about it at all. So let's check that out in action. We'll go here, and what we'll do is we'll close this daplib package in the Explorer, and we'll open client and go into the source there. And here you will see a folder called pages, and there's a file called dapp.js. Now this dapp.js is this application here, and this is your application. You can build it, modify it however you want. And this frame here, that's the Decentology sort of Dap Starter work environment. But your Dap, you can click this little arrow and you can pop it out, and you can see that it's only your Dap. It is nothing else there. And so, but we put it inside this window here as a convenience, so you can switch between things and etc. But over here on the right, you're seeing the exact source code that generated this page. Now we use a library called lit element, which makes it easy to embed HTML into JavaScript, and it has lots of attributes, etc. So you don't have to write a lot of code. And you can see here that this code is right here. So let me show you hot loading. I'm going to change this to say, hello, decentralized world. And now I'm going to hit Command S on my computer, hands up, and bam, it reloaded automatically because it detected the change, and you're done, right? So it's as easy as doing that. Now, what if you wanted to build an IPFS kind of app like I was showing you? Well, let's do that. First, let's clean up this a little bit. And we'll leave this in here. It's got a margin top, and hit save. So all of this goes away, and we've just got the title. All right, let's get now go back here and in the same client source subfolder called harness. You will find a page corresponding, a script file corresponding to each of the harnesses. So I want to go to the IPFS harness, and you will see in here that we've got these components. So we've created web components for you to make it super easy for you to work with this code. So these action cards I was showing you earlier are right here, and I have an action card for add document. I'm going to do is copy that from here. I'm going to go over to my Dap page here, and I'm going to just paste that code here and save it. So now I should get that code from the harness over here. And sure enough, I did. And to show you that this is not just some empty UI, this is operational, I'm going to hit Browse Files. I'm going to choose another picture or two and hit Open and hit Submit. And you can watch here, it's still going to submit a transaction. And bam. So it submitted those documents. And you can see that this got pulled out here, but it is still working exactly as it was there. So Dap Starter really makes it easy for you to build. You just edit some code and iteratively build out your application. So once you get started, you get more comfortable with it. You can then start enhancing the code and thinking of the core functionality that you want to build and modify it. We've done all this in terms of getting started with the Dap development. If you recollect earlier, I did Yarn and I did Yarn Start, and in less than 5 minutes, I had a full Solidity smart contract, a full UI, and in addition to that, we also have a server API. So we have here for all the contract endpoints that are there, we have an API also, so you can interact with this if you want. So if I execute this one, contract run state, you can see that it returns result true. So we've thought through all of the different scenarios, etc., that you need in order to build, and we've tried to make your life super, super simple. So that's basically the gist of what Dap Starter is about. This was what I wanted to convey to you today. I'm going to pause here and answer some of your questions, and also give an opportunity for the women in the audience to go ahead and enter their names in there. So far I see, let's see, how many do we have here? Yeah, as Vinayak said, the recording will be shared with you. All right, so we've got 1, 2, 3 women, that have responded. That's great. Hopefully more of you will respond. But let's take some questions. Are there any questions here? Don't be shy. Anything you want is fair game. Please ask away. I can answer your question about anything code related, about Dap Starter. A lot of what you showed us was UI development. What happens if you wish to edit the smart contract? All right, very good question. Let's do that. And as I mentioned earlier, this is all integrated and hot loaded. So if I go into my contracts here and there's Dap state here, let's go ahead and say that we want to add a new variable here. Let's say it's uint 256 public my demo equals 0. So I do that and I hit save, and it is going to momentarily recompile and redeploy that. It's probably going to give me a compiler warning that I have an unused thing in there, but you can see that it recompiles and redoes, and it regenerates everything for you. So this is a live environment. It is not just a UI. It is the full stack. Everything you need to build a production grade Solidity application for the Ethereum blockchain is there. There is nothing missing here. Yeah, exactly. Even the contract is hot loaded, recompiled, redeployed. You literally don't just focus on your code, what you're building. We'll take care of everything else for you. And since I have a couple minutes, I do want to tell you that if you go to our website, actually, let me post a few links here for you. So I'll first post a link to this application, Dap Starter. So do that. And Manpreet says, sir, what we were doing when we were changing the active state in the browser. So I think you're referring to the contract run state. So what we were specifically doing is we were changing this variable to true or false. It's very simple, but here's what it's doing. In Solidity, you have the ability with every function to use something called a function modifier. That is code that is called every time a function is run. So we have here a function modifier called require contract run state active. And what it does is check the value of that contract run state variable, if it's true or false. And if it's false, it aborts immediately. So by having that contract, that modifier available anywhere that you want to prevent an action from happening if the run state is paused. For example, if this was a DeFi application, decentralized finance application, and you were in the process of seeing that there's a hack going on, well, you want to go pause the contract because you don't want to lose all the money in it while you figure out what's going on. So you would run that, and if you have implemented this architecture, then it's literally just an on-off switch implemented with a variable, a Boolean variable, that checks to see if it's true, continue. If it's false, abort. That's all that is. So hopefully that answered your question. Uh, one of the things that I wanted to share with you is we have a very active community. This is where you can go for help. It's in Discord. I'm going to post the link here, and I hope you will join us in Discord because we have something really, really exciting going on right now. We just, as I may have mentioned, uh, uh, about a week ago, we announced that we've closed on our seed round of funding of $4.3 million. And that is for us to build out something called the Hyperverse. So this is an open platform that will allow any developer, such as you, to create a smart contract module, deploy it on there. And if you have something well written that other people can use, you can add a fee on there, and forever, for the rest of existence, as long as that blockchain exists, every time someone uses that, you get paid. And there's no way to block that or change that. And so that's called the Hyperverse. And you can go to our website. I'm going to pull it up here. You can go to our website and learn about the Hyperverse. I'll go ahead and paste the link for you. But coming up soon on November 8th, we are going to start a hackathon for Web2 developers to build on this and start. We have some awesome rewards, etc. So I hope you will join our Discord and create your first Dap Starter project and really start building and making your journey into Web3. I'm on Twitter. I'm quite active. Here's my handle in chat. My colleague Niharika is also, she usually does this, but she couldn't be there for this session. But she is also available. And I'm going to put, she is your ETH girl on Twitter. And I posted that also. So I'm looking forward to engaging with you guys on Twitter, on Discord, etc. And really hoping that you will take the plunge into Web3. I really hope that you found this webinar useful, and I look forward to catching you online again in the future. So Vinayak, if you're on, back to you, sir.
Thank you so much, Nick, for this enlightening lecture. I believe everybody must have understood how to get started in decentralized applications and how to get started making decentralized applications. And we urge everybody to join the Discord group so that if you guys have any problems while building it, right, you guys can directly communicate it in the group, where the Discord group is actually quite active as well. All your problems could be sorted there, right? And definitely ask questions so that you can understand it better, right? Uh, Thank you so much, Nick, and I believe it was really amazing. Everybody should have definitely enjoyed it. We'll share the links with everybody so that they can keep on connecting you guys.
Great. Yeah, thank you so much, guys. I really appreciate your time, and look forward to seeing you online. Bye bye.
Thank you. Thank you all.